Dan, nice to have you here.
Thank you for having me here.
You've been very active in standardization, not only in the IETF, but also in IEEE. Can you tell a little bit about your activities?
Well, I'm involved in these activities. Actually, I'm involved in network management for the last 23 or 24 years. So I started at the end of the 80s working on as a software engineer, building network management applications for what was an emerging technology that was called Ethernet. And then I kind of climbed atop the layers to IP routing, switching, and all the other wonderful things related to the internet. And by the time I was starting, I identified two very interesting protocols that were competing for performing the task of network management of devices and networks, the type my company was manufacturing. One was supposed to be a short-lived solution called SNMP, and the other one a long-lived, wonderful solution called CMIP. So I started to learn SNMP, and I'm afraid that I'm still doing it like 24 years later, but of course a lot of other things have been added, and a lot of things happened around the internet. And I became indeed involved in management of internet, management of the World Wide Web, and currently I'm working both as an architect and also in the standardization of management solutions in the IETF, in the IEEE, in the W3C, and a few other organizations, of course, in my company, focusing on management of voice and video solutions.
You mentioned earlier you've been working on CMIP as well as SNMP, and SNMP was the short-term solution.
Right.
Why did CMIP fail?
I believe that the first, there is always a combination of timing and industry status. So I believe that at that point in time, let's say the state of art of implementation into devices was not up to coping with the complexity of CMIP. I think that things had happened 10 years later, or today the landscape would have been different. But at that point in time, SNMP was simple enough, but not simpler than it was necessary to provide the basic functions of management. And I believe the situation is still there, at least for some of the applications that we are dealing with in the internet. And of course, for things that SNMP is not sufficient or insufficiently well defined, people have invented other protocols and other applications. Some are in the standard space, some are in the proprietary space.
If you look at the discussions that we had in the early 90s between SNMP and CMIP, you see that many of the discussions focused on the use of UDP versus TCP. And the SNMP community decided to go for UDP and CMIP TCP. If you look back, do you think that was, say, the right decision of SNMP to focus on UDP?
Absolutely. This is part of, I think that is part of the simple but not simpler than necessary case. And it was an issue of the state of development and the state of stability of the networks at this point in time. So in specific situations of crisis or congestion, there are characteristics of the UDP transport that are extremely useful for management situations.
If you look at monitoring, I can understand that you transport it over UDP. But if you look at configuration, it sounds to me a bit strange that you're not using a reliable transport there.
Well, if I am to consider, for example, I wouldn't fly an airplane that is configured by SNMP. That's for sure. And if I wouldn't, I hope that, let's say, the critical networks that are being configured at the basis. The stability of critical networks or networks using critical applications are also, if using SNMP, also using something else for configuration purposes. But for many practical applications, SNMP is still being used in proprietary and sometimes in confirmed world environment, and it works pretty well. Wherever we need more, we have now netconf, and we have some other applications, and the world is changing according to the needs.
We talked about the IETF. We talked about, say, CMIP, so OSI. You are also very active in IEEE. Can you say a little bit more on management standardization in IEEE?
It's an interesting case because you probably know that the initial development of the management interfaces for the IEEE technology happened in the IETF. So we had the Hub MIB, which was doing Ethernet standardization, and we had the Bridge MIB, which was doing Zeta 2.1 technology management. This was moved in time to the IEEE on the principle that the IETF is good in developing protocols and establishing the tool set, defining the tool set that is going to be used by other organizations, while the specific technology experts are actually not coming, the majority of them are not coming to the IETF but working in those organizations. So in time, this principle was understood by the IETF and the IEEE, and by the way, I am also acting as a liaison of the IETF to the IEEE Standard Association, and I can say there is a very good relationship between the IETF and the IEEE, and the management applications are kind of one of the best examples of cooperation. In time, we have taken technology developed for the protocol development in the IETF, transferred it to the IEEE. We are still providing and helping the IEEE with reviews and with expert advice using the MIB doctors team. And we start discussing with the IEEE also about netconf and young technology. I believe that in a few years we will see the newer IETF technologies for network management transferred as well to the IEEE. So it's a process that proved to work in this case, and maybe a model that can be followed by in the relation between the IETF and other organizations.
You just used the term MIB doctors. What exactly is MIB doctors?
MIB doctors is an experts team. So we have in the IETF this concept of expert teams or directorates. Their purpose, their scope is chartered to help the area directors in providing advice on specific technology items. The operations and management area has a few of these teams, and we call them doctors. Don't go for medical advice to them, however. And this team actually is a gathering of experts, in this case in the management information-based technology, so SMI and SNMP, and they are doing reviews for MIB documents in the IETF and providing advice to working groups in the IETF, and also on request for out of the IETF, and IEEE is one of the organizations we are working with and helping.
If you look at the early SNMP standards, then we had the MIB2, and nowadays you see that we have many separate MIB modules. Why did they split up the MIB2 in these different MIB modules?
Well, actually, I would kind of correct you, because those MIB modules are actually part of MIB2. So from an architectural and concept point of view, there are exceptions, but this should be discussed exceptions, but most of the standard MIB modules under MIB2, and they can be looked at as extensions of MIB2.
But how do you define then the term MIB2? It's not the RFC. It is, say, the naming?
Actually, it's the belonging under the MIB2 management root. Yeah. So all the standard MIBs are defined under, and the fact that they split into maybe today I believe that we have hundreds already in the low hundreds of MIB modules. It's an issue of scaling. So of course, one big MIB modules became completely unmanageable. So we started to split and scale. But the fact that they are all from an OID's organizational point of view, architecture under the same root actually helps with the tools and helps with identifying when a specific module is an extension, a standard extension, or rather belongs to the proprietary space.
Which MIB modules are currently the most popular ones? The interfaces MIB, I believe that which is derived from the original MIB2, I believe is widely used. The Entity MIB, which got recently a revision, is also quite widely used and extended for specific devices management. The remote monitoring MIB, I believe, as well. It had a peak of popularity, which we are maybe beyond it, but I believe that it's still quite widely in use, and some of the MIB modules related to routing, even if some of their implementations kind of ignore the read-write mode and use them into read-only mode. These are from the IETF space. And what is now the IEEE space, the Bridge MIB modules, I believe that they are also pretty wide used. You mentioned the Entity MIB. What exactly is the Entity MIB? What can you manage with it?
The Entity MIB helps you understand what is running in your network as a device and application. There are basically the concept is very simple. There are basically two tables, which one is of physical entities and the other one is of logical entities. And those tables provide further indexing. The indices of this table provide further indexes also for extensions. So we can very easily, after we discover the device managed by SNMP, if that device is running into a network, if that MIB module is running into a network device and supports the Entity MIB, you can get more information about what the physical device is, what functions it performs in the network, some information about its structure, if it's a modular device that has some incorporated entities like blades, power supplies, and it's read-only, which basically allows for the information to be retrieved from the device and only by the device. So it is information that vendors want and can expose to managers in an authoritative manner.
If you compare the Entity MIB to the Host Resources MIB, what are the differences?
The Host Resources MIB goes more into details related to hosts themselves. So it's specifically looks at the end user machine, or if it's a network device, to the host characteristics of the end user machine. The Entity MIB is a little bit more generic, and if there is a focus, I would say Entity MIB provides more information about devices, Host MIB about the host specific aspects of the device or the machines they are running in. but they are complementing each other, so they are two useful and complementary MIB modules.
Also, in your role as area director, you have seen a lot of activities within, say, the SNMP framework. Are there specific things that you miss and where you think, hey, we should have done more there?
So first of all, my role as area director happened in time between 2006 and 2012. I believe that that period was a period of change from the point of view that the community, the IETF at large, understood better the fact that there is no one protocol fits all needs type of concept. There was a belief in the IETF in the 90s, and it was very well intended, having like one protocol and one type of data model that tries to solve as many problems as possible is a very good goal, but it proves really not to work in many cases. So much of what was done during my period as area director was in understanding that we are migrating from a one protocol fits all to more to a tool set type of approach in managing the internet. And this is where IPFix, which was started previously, developed and actually caught and got popularity in being used for retrieving information, monitoring information, and performance information. This is a time when NetConf made progress, and Yang started and finished its first phase, and this is for configuration purposes. And that was also the period when we established the Performance Monitoring Directorate, which is another directorate under Ops, which helps other working groups in the IETF define performance metrics according to a shared template. I believe that we kind of broadened the purpose of standardization within the IETF during that period. Did we take all the good decisions? Probably not. Most of the decisions we have taken will be useful. I hope so, but time will tell.
What are the new activities that you expect? Use of REST technology for configuration management, RESTconf?
There are a few new things that are happening in the IETF and around. So use of REST type of interfaces and the definition of simpler protocols or ways of accessing information using HTTP is one of them. And we see this, for example, in a new activity that we had yesterday at the IETF meeting this week, end of July 2013. The first meeting, it's a LMAP working group, which is about the monitoring of performance on large-scale networks. So this type of requirements are new from the sense that they put in front of the IETF community the requirement of scaling basic performance management to the scale of the whole internet or very large networks, very large operators. We are talking here about getting performance information from hundreds of thousands of hosts, for example. And this needs specifically trimmed, well-trimmed and focused tools. This type of interfacing would be useful. Another group of applications actually go to a more sophisticated or maybe to more complex type of tools, and they may lead to the identification the need to identify such tools. And this is about security assessment, for example. Another work that is starting at and has its first meeting at this IETF is about security assessment and continuous monitoring, which is a specific activity about how you understand what you have in your network from a point of view of security assets, how you retrieve information, and how you automate some of the security actions. This again puts the requirements of another sector and class of applications, the IETF, for possibly new protocols, or maybe using or working with protocols that have been developed by other organizations. This work is just at the phase of understanding the use cases and defining the basic architecture. So we do not know exactly where it will go, but it may result also in work in the ops area.
You mentioned the large-scale measurements. Nowadays, you see a lot in the news about NSA, PRISM, and monitoring everything that's happening on the internet. Is it the IETF? Is there any discussion about, say, this, non-technical aspect, or is that something that is not being discussed?
It is being discussed. It is being discussed, and it is a concern both at the level of the IETF leadership, which has taken a very clear stance in the past, which I believe is still valid today, about network neutrality and about not involving the IETF design protocols into actions that can basically cause problems to security or confidentiality of the information. And if you are watching the list, the mail lists, you see that this is something that is of concern, of high level of concern, also from people from the community. So I guess that we have taken in the past, and we will see probably even more focus in the future to the security aspects of the protocols, including the fact that we need to be very careful so that the tools and the protocols we develop cannot turn into tools that can attack the internet, or tools that can put in danger the confidentiality of the information that is being carried.
And the people behind, the privacy of people.
And privacy of people behind, which is, of course, the internet is built for end users, and that's something that probably as engineers we sometimes forget, but we should not, and we should remind that behind each host there is a user that the internet is serving.
I think this is a very nice concluding statement. Thanks for the interview.
Okay, thank you.
Thank you.